In this video, we will introduce two new tools coming out of the agent development world. The first is CrewAI and the second is AgentOps. CrewAI is a multi-agent framework and AgentOps is an agent observability tool. CrewAI is one of the leaders in their space, as is AgentOps. For reference, here's a list showing the leading open source multi-agent frameworks ordered by GitHub stars as of October 2024. If you want to code along step by step, you'll need to install two tools onto your machine, Docker Desktop and VSCode. Both of these tools are free and offer extremely easy to use installation processes with support for Mac, Windows, and Linux. I'll be using Mac in this video, but the general process of what we'll be doing will be the same for Windows or Linux. Let me now show you how I installed these two tools on my Mac so you get a feel for how easy it was for me. But if your experience is not as straightforward, please leave a comment so I'm aware, or I suggest you put detailed descriptions of the issues you're running into either Google or ChatGPT for help troubleshooting. Here's how to download and install Docker Desktop on Mac. Go to the official download page, download the appropriate version. For me, this is Apple Silicon. Open the downloaded DMG file and drag and drop the docker.app icon into your applications folder. I've already done this, so I'll click stop, but that's it. It's that easy. And here's how to download and install VS Code on Mac. Go to the official download page, download the appropriate version. For me, this is Apple Silicon. Unzip the downloaded zip file and drag the Visual Studio Code.app icon into your applications folder. I've already done this, so I'll click stop, but that's it. It's that easy. After installing VS Code, you'll need to do one last thing. Open VS Code and come over to the extensions marketplace on the side menu, and you'll need to install two extensions. The Docker extension. You can search for it in the search bar, and once you find it in the panel, you can click on it, and then you'll see these buttons right here. You can click to install it. Should only take one click. It's that simple. B, you'll need the dev containers extension. You should see some buttons right here. You can just click to install it. Super simple. And that should be all the setup you need. All right, here we go from scratch. CrewAI, AgentOps, let's do it. Here we have an empty folder somewhere on our computer that we're going to use as our starting point. First, we're going to set ourselves up with a very solid foundation to build this CrewAI application on top of. Or I should say, I find this foundation to be very solid, but let me know what you think in the comments. Let's start by adding the following folder and files to this empty project. At the root, let's create a folder called .dev container. Inside of this .dev container folder, let's create a file called devcontainer.json. And at the root of this project, let's also create a file called dockerfile.dev. Here is the content we will paste into the devcontainer.json file. You'll understand what the content of this file does shortly. And here is the content we'll paste into the dockerfile.dev. You'll understand what the content of this file does shortly as well. Alrighty, now that we have these files set up, we can launch our dev container. We won't go into detail, but when I say launch our dev container, what I mean is we will build a mini computer that will run on top of our actual computer. Inside of this mini computer, we'll play around with CrewAI, close or kill the mini computer when we're done, and then our base machine, aka our laptop or desktop or whatever we're using, will be left clean as if nothing ever happened. AKA, this is a fantastic technique for experimenting with new software without cluttering our base machine with potentially messy software installations. Here's how we build our dev container. In VS Code, we type Shift-Command-P, and that opens this menu called the command palette. Inside the command palette, we look for an option that says Dev Containers, Reopen in Container. I think this menu option will only be available if you have the Dev Containers VS Code extension installed. When we select it, our dev container will begin being built. In my experience, building a dev container takes about 1 to 3 minutes. It depends on a number of factors like how fast my machine is or the details of the dev container I'm building, etc. But After the dev container is, right? So that took like a minute, maybe even less. But after a dev container is built, we can shut it down, turn it on, shut it down, turn it on. Shutting it down and turning it on only takes a few seconds. Anyways, it might take longer for you. It might be shorter. I don't know the details of your environment, but hopefully that gives you a feel for how this works. Let's quickly test out this development container to make sure it's looking good. As CrewAI is a Python-based tool, let's confirm we have Python installed. And we do. And let's try running some Python code to make sure that works too. So here I've created a file called main.py. Let's add some code into this file and pass this main.py file to the Python interpreter on the dev container. And it looks like it works. If we look closer at the dockerfile.dev, we can see we asked Docker to build us a mini machine with Python 3.12 installed on it. And we also asked for some additional C++ libraries to be installed as well, because these will be needed by CrewAI. The remaining lines of this file outline where we want to work inside of this dev container. For example, if we enter the pwd command or present working directory on our dev container, we can see we are in a folder called code at the root of the file system. If we were to look at the root of the file system on our base machine, we would not see any folder by the name of code. The mental model to keep in mind is that we have two separate systems running on our machine. We have the dev container and we have our base machine. Each of these two systems has its own file system and is capable of having completely different software installed. Moving forward, we're going to be working inside of the code folder at the root of the file system of the development container, or our mini machine that's running on top of our base machine. Hopefully that makes sense. Let's remove this main.py file that we use for performing a quick hello world test and move along. Now that we have a solid foundation, we can start building our CrewAI project. The way we're going to do this is not recommended at all, but for the purposes of learning how CrewAI works, it will be fantastic. What we're going to do is build up a simple CrewAI project from scratch, one file at a time. Here on CrewAI's documentation, they provide an outline of what a CrewAI application looks like. We can see a CrewAI project contains a source folder. Inside of the source folder, we have another folder. Here it's called My Project. Inside of My Project folder, we have a main.py file, a crew.py file, a tools folder, a config folder. Inside of the config folder, we have an agents.yaml file and a task.yaml file. Okay, got it. So in the same way a chef can take a look at a recipe, get the gist of it, and improvise on it when cooking a dish, we are going to build an application that follows the general outline of what a CrewAI application looks like. Let's add the following folders and file to our dev container. At the root of our project, let's create a folder called source. Inside of this source folder, let's create a folder called our crew of agents. And inside of this our crew of agents folder, let's create a file called main.py. When a file ends in .py, it indicates to us that it will hold Python code. When you're looking at Python projects, it's very common to see some file called main.py. For our purposes, main.py will be the file we use to launch our agents and give them tasks. For the beginners watching, I find it important to tell you that when programming, we can call files, folders, and many other aspects of the code we write whatever we like. For example, we could have called main.py blah.py. Let me show you. Let's rename main.py to be called blah.py. And let's add a simple instruction into blah.py. For example, this is the instruction to print telling my agents to do something to the screen. And then let's pass this blah.py file to the Python interpreter. And then you can see we get the text printed telling my agents to do something. Names are just labels. And when programming, there are an infinite number of ways to organize your code. In practice, though, so it's easier to collaborate and build with others, we follow conventions. These conventions are learned through experience over time, so be patient if you're feeling unfamiliar with what you're looking at. Watch the whole video and come back to any confusing parts later. Let's rename this blah.py file back to main.py because that's more conventional, and quickly confirm that everything works. And let's pass the main.py file to the Python interpreter. And as we can see, everything works just the same. Now, instead of simply printing out the text, telling my agents to do something, let's add some code provided to us by the team at CrewAI. We could add all of the code of this project into a single file, aka this main.py file, but that is not advised, as over time that would mean we would constantly be scrolling up and down across the main.py file as we added more lines. Therefore, let's add another file to our project called crew.py. Let's add this crew.py file inside of the our crew of agents folder. And here is the content that we will paste into this crew.py file. And we can call the code in this crew.py file from the main.py file like so. Okay, remember this docker file.dev file and how it included this line that says Python path equals /code? This line configures the Python interpreter on the dev container to look for code we import at this specified path. For example, if we look at the path of the crew.py file, we can see the path is /code/source/our crew of agents /crew.py. I know, in the main.py file, paths are specified with dots in our imports instead of slashes, but in this context, it means the same thing. Also note that we don't have to write .py at the end of Python files we import in our code. Quick side note, so in my VS Code, I was seeing a warning that said select interpreter. The warning was showing right here. VS Code should automatically detect the interpreter path on the dev container, right? So hopefully you don't see this issue, but I've seen it happen from time to time. And if this is happening for you, this is how you fix it. In VS Code, type Shift-Command-P, that'll open up the command palette, and search for an option that says Python Select Interpreter. If you don't see this menu option, you can start typing Python. You'll start filtering out the menu options, then you can select this one, right? This is the appropriate one, Python Select Interpreter. Hit Enter, and that'll take you to a submenu. As I mentioned, VS Code should automatically detect the interpreter path, right? Hopefully you see a recommended option. You can just select it, and that'll make the warning go away. If for some reason you don't see a recommended option in the submenu, you can manually enter the path to the interpreter on the dev container here, right? By selecting this option, enter interpreter path. The path to the interpreter is /user/local/bin/Python. Then you can click enter, and that should make the warning go away as well. If you recall, I guess 30, 60 seconds ago, crew was colored white, as was the our crew of agents symbol, right? And after I selected the interpreter path, everything became colored appropriately as I expected, etc. So, like I said, if everything's colored as you're seeing it, or everything's working smoothly, ignore this section. But if you have a warning showing somewhere in your VS Code UI that says, select interpreter path, I just showed you how to fix it. So let's move forward. Let's try running our crew of agents for the first time. Module not found error, no module named CrewAI. When we fed this main.py file to the Python interpreter, the code or the instructions outline began being executed from top to bottom. On line 1, you can see we're doing an import. We're importing source.ourcrewofagents.crew. That popped the Python interpreter over to the crew.py file. In this file, you can see on line 1, we're also doing an import. We're importing this thing called CrewAI. And you can see, as indicated by VS Code, it has this yellow squiggly line underneath it. If we hover over, we see the text, import CrewAI could not be resolved. So, as indicated by the error in the console, and as indicated by VS Code, this CrewAI thing is nowhere to be found. So what we're going to do is add this CrewAI thing to our dev container, and hopefully this error will go away. Python has a system in its ecosystem called PyPy, which is short for Python Package Index, that allows us to easily download code published by other members of the Python community. If we enter this command to our terminal, code published to PyPy by the CrewAI team will be downloaded to our dev container in a way that the Python interpreter can access. If we omit the version number and just type pip install CrewAI, the latest version of the CrewAI package will be downloaded. But to not confuse things, especially for those following along, let's just download this version, which is the latest version as of the time of recording. It looked like the installation worked, and we can see that the warnings in VS Code went away. So let's now try running our crew again and see what happens. Okay, we see a different error, which is fantastic. That means we fixed the CrewAI import error. But now we're seeing an error that says, file not found, no such file directory, code source, our crew of agents, config/agents.yaml. I wonder what this could mean. The way CrewAI is designed requires us to add this agents.yaml file at a very specific location. So let's add this file like so. Inside of the Our Crew of Agents folder, let's create another folder called config. And inside of this config folder, let's add a file called agents.yaml. Let's paste this content into the agents.yaml file. As of the time of recording in October 2024, the content of this agents.yaml file has to follow a very specific structure. With no indentation, we put the name of each agent in our crew, and then at one level of indentation below the name, we specify the agent's role, goal, and backstory in natural language. There are other properties that we can specify for our agents, but these are the required ones. All the other ones are optional. FYI, this way of outlining configuration is extremely common in programming and is called YAML format. YAML allows you to specify key value pairs of information that can be nested at various levels. In the context of a YAML file, this angled bracket character is known as a folding block symbol. This character allows you to write the value associated with a key or property on multiple lines instead of one big, long line. The way we connect this agents.yaml config with the crew in our crew.py file is like so. We reference the relevant key so that it lines up with the method name that generates each agent. And let's do this for the other agent real quick as well. And that's it. And oops, we never imported the agent class from CrewAI. Let's do that. And now all of our warnings go away and we're looking good. Taking a step back, we can see that our crew class is coming together nicely. For the beginners watching, in the context of programming, a class is a blueprint for creating things. To use another cooking analogy, let's say that we have the recipe for a dish. The recipe is not the dish. It's the instructions for how to make the dish. Similarly, in programming, a class defines the ingredients or components of code. When we pass a class to the interpreter of a particular programming language, for example, the Python interpreter, we are left with runnable code that implements the blueprint defining the class. We can see in this class, we're defining a group of two agents, with one of them being George Washington and the other being Thomas Jefferson. Now that we've defined the details of our agents, let's try running our crew again. Okay, we see a different error, and that's fantastic. That means we fixed the error related to the missing agents.yaml file. But now we're seeing an error that says file not found, no such file or directory, code source, our crew of agents, config/tasks.yaml. I wonder what this could be. In addition to configuring our agents, the CrewAI framework requires us to specify a file called task.yaml that outlines the tasks we want the agents in our crew to perform. So let's create this task.yaml file at the exact location given to us by this last error. Inside of this file, let's paste the following content. As of the time of recording in October 2024, the content of this file has to follow a very specific structure. At no level of indentation, we specify the name of each task, and then at one level of indentation below the task, we specify its description, its expected output, and the agent we want to assign the task to. The way we let our crew class or blueprint know about the tasks outlined in this tasks.yaml file is like so. We come over to the crew.py file and add the following code. And we have to format this according to Python's rules. One sec. And that's looking good. We just have to import the task class from the CrewAI package, as well as the task decorator. If you've never seen a decorator before, this is a decorator. All a decorator is a fancy way of writing a function that takes a function as an input and returns another function. Don't stress out about it. Just look at this stuff from a high level. Zooming out, we can see we're designing our crew to consist of two agents who will work together to accomplish two tasks. By default, CrewAI executes the tasks outlined in the task.yaml file sequentially from top to bottom. So here we can see we're assigning Thomas Jefferson to write us a Declaration of Independence, and the Declaration of Independence he spits out will be fed into George Washington, who will then generate a military strategy for us. There are other patterns besides sequential execution when giving groups of agents tasks to accomplish your goals, but we'll leave those topics for another video as we're keeping this super simple and beginner friendly. All right, let's try running our crew again and see what happens. All right, well, we get a different error. So we fixed that missing task.yaml file error. That's great. And now we're getting an error that says something went wrong. Kickoff should return only one task output. So sometimes when you see errors, it's very straightforward, but other times it's not. So if we come to crew.py. Okay, so this should have been written like so. Excuse me. So yeah, I think that should work. And let's run our crew again and see what happens. Okay, cool. Yeah, so we have to define the tasks inside of our class, and we also have to link them with the crew object here. So hopefully that makes sense. And now we're getting a different error. This error says OpenAI exception, API key client option must be set, right? Authentication error. I wonder what this could be. This error is happening because we haven't authenticated our project with OpenAI's platform. CrewAI supports various LLMs for powering the agents in a crew, but by default, it uses OpenAI. If you're unfamiliar with the term LLM, an LLM is the part of an agent we would consider its brain. The details of how an LLM works can be explored outside of this video if interested. But for our purposes, we'll be calling an LLM powered by OpenAI via its API each time one of the agents in our crew is performing the task currently assigned to it. Connecting our project with OpenAI is simple. All we have to do is come to platform.openai.com in our browser. And if this is a new account for you, you will have to add a couple of dollars. OpenAI's pricing model is usage-based. It's like a gas station. You will need some credits. And after you have that set up, you can browse around and look for the API keys section. API keys have been replaced by project API keys. View project API keys. So here we can create a new API key. So let's click this button and we can leave everything as default and click create secret key. And make sure you keep this private, but let's copy it and we'll be using it later. So make sure that no one else besides you gets access to this API key. And here is how we securely add this API key to our project. For the beginners watching, pay attention closely because this technique is very common. At the root of our project, we're going to create a .env file. Inside of this .env file, we will type on a single line in all caps, OpenAI _ API _ key equals, and then we will paste in the API key that we provisioned on OpenAI's platform. We'll save this. And the next thing we'll do is install this special package called python.env. This is the version that we'll be using. And then we'll come over to the main.py file and add these lines. These lines will read in any secrets that we have in the .env file and make them available to our code. So now if we run our crew, let's see what happens. Hopefully this should work. And yeah, things look like they're working. The console looks beautiful. And interesting. We only see George Washington performing a task. Let's see what's going on. Oh, I see what happened. So the decorator was accidentally deleted. So if we run our crew again. Yep, now we see Thomas Jefferson writing the Declaration of Independence. And when he's finished, George Washington will write us, or I guess he'll come up with a military strategy. right? There goes the Declaration of Independence, and here is the military strategy. So that's fantastic. We have a working crew. Remember, the way we built up our crew of agents up from scratch manually is not recommended at all. But for the purpose of learning how CrewAI works, I hope you found it useful. Let's do one final thing before we wrap this up. Let's show how we can track our agents using a tool called AgentOps. AgentOps is compatible with many different multi-agent frameworks and allows us to track metrics such as the cost of the agents in our crew, how long it's taking the agents in our crew to complete its tasks, and it'll also track any errors our agents run into as well. The process of integrating AgentOps is extremely easy and is very similar to how we integrated with OpenAI. To integrate with AgentOps, come over to app.agentops.ai. If you haven't signed up already, create an account and come over to the API key section once you're logged into your dashboard. You should already have an API key provision for you by default, and copy this API key and come back to the CrewAI project that we've been building. And inside of the .m file or the .env file, let's add a new line, and in all caps, let's write AgentOps underscore API underscore key equals, and then paste in the API key that you copied from the AgentOps dashboard. Save. And then let's come over to the main.py file and let's add the following lines. Make sure you add these lines after the load.env command so that the AgentOps API key is available to be used. And make sure you add this AgentOps tracking code before you call your agents so that they're ready to be tracked before doing tasks. But hold up. Notice how VSCode is giving this little warning indicator telling us that there's something up with this AgentOps import. And we've seen this before. It's because we haven't installed this package yet. So let's type this pip command into our terminal. And after the installation completes, we should see this warning go away in VSCode, and it does. So now let's run our crew again and see what happens. And when our crew is done, we see some analytics, right? We see the cost, and we see this link that we can click on and inspect. We can see it gives us a dashboard with an overview of this session that we just had with our crew. And this can be very useful for troubleshooting issues and getting an overview of what's going on. As you leverage agentic workflows more and more, you're going to need a tool like AgentOps for monitoring what's going on. Okay, let's now wrap this up. So I'm going to move these two lines to the top of the file just to be a bit cleaner. And that looks good. And let's also record all of the PyPy packages that we use throughout the building process. So the conventional way of doing this is to create a file at the root called requirements.txt. And inside of this requirements.txt file, let's paste the following content to record the various PyPy packages we used, as well as their versions. And now let's store a copy of this code on GitHub. Add a file called .gitignore. And inside of this .gitignore file, let's add this entry. Git is no longer tracking the .env file, which is great. That's what we want. Never expose your API keys. Let's create a repo on GitHub, then add a remote to our local Git configuration, and then push our code to GitHub. And when we take a look at our code in GitHub, We don't see the .env file. That's what we want. And we also need to upload all the tags because I've been tracking each step along the way. So we'll say git push -- tags. Fantastic. Then when we reload, yeah, fantastic. So you can easily follow along. So what we can do now is close our dev container and poof, it's like nothing ever happened.